Ever heard of Bitcoin, NFTs, or maybe just blockchain and felt a little lost? Well, you're not alone. It sounds complex, but at its core, blockchain is a beautifully simple idea. And today, in about 10 minutes, we're going to break it down so clearly you'll feel like a crypto wizard. So, imagine you're running a business, or even just keeping track of your personal finances. How do you record transactions? Typically, you write them down in a ledger, or maybe use a spreadsheet. If you're a big company, you have massive central databases. The problem? Centralization. All that power, all that data, sits in one place. One point of failure. If that central server goes down or gets hacked, your data is gone or compromised. Trust issues. You have to trust whoever controls that central ledger not to mess with it. They could change entries, exclude people, or even shut it down. What if there was a way to record transactions that was distributed? No single person or company owns it. Transparent. Everyone can see what's happening. Secure. Nearly impossible to tamper with. That's exactly what blockchain set out to solve. Think of blockchain not as a single database, but as a digital distributed ledger that's shared across a network of computers. Let's start with the name, block, plus, chain. Each block is essentially a container for data. What kind of data? Well, if it's a Bitcoin blockchain, it's transaction data. Who sent what to whom? But it could be any kind of information. Medical records, supply chain logistics, even votes. Inside each block, you'll find transaction data. All the details of the transactions bundled together. A timestamp. When these transactions occurred. A unique identifier, or hash. Think of this as the block's digital fingerprint. It's a complex string of numbers and letters generated by a cryptographic algorithm, and it's unique to that specific block and its contents. Even changing one tiny piece of data inside the block would completely change its hash. Now for the chain part. This is where it gets really clever. Every new block also contains the hash of the previous block. Imagine our unique fingerprint. It's now embedded in the next block. This creates an unbreakable link, a chronological chain of blocks. If you try to go back and alter a transaction in an old block, its hash would change. And because that old hash is embedded in the next block's hash would also change. This would cascade all the way up the chain, effectively breaking it. This linking mechanism is what makes blockchain incredibly secure and virtually immutable. Meaning, once data is recorded, it's almost impossible to change or delete. To tamper with even a single transaction, you'd have to change that block's data, recalculate its hash, then go to the next block, update its previous hash pointer, recalculate its hash, and so on for every single subsequent block. And here's the kicker. You'd have to do this across thousands of computers on the network, which brings us to the next critical component. Remember how we said blockchain is a distributed ledger? That means copies of this entire chain exist on thousands, sometimes millions of computers around the world. These computers are called nodes. When a new block is created, it's broadcast to all these nodes. Before it's officially added to the chain, the majority of the nodes must agree that the block is valid. This process is called consensus. Think of it like this. Someone tries to forge a block on their computer. Their version of the chain won't match the thousands of others. The network will reject their fraudulent chain because the consensus is with the vast majority of legitimate chains. This decentralized nature means there's no central authority to hack or corrupt. The network collectively verifies and maintains the integrity of the data. So how do new blocks get created and added? This is where concepts like mining and staking come in. Mining, proof of work. In systems like Bitcoin, computers, miners, compete to solve complex mathematical puzzles. The first one to solve it gets to add the next block to the chain and is rewarded with new cryptocurrency. This work proves they invested resources and makes it incredibly difficult to create fake blocks. Staking, proof of stake. Newer blockchains often use staking. Instead of solving puzzles, validators put up a certain amount of their crypto as collateral. They are then randomly selected to validate new blocks. If they act dishonestly, they can lose their staked crypto. It's an energy-efficient alternative to mining. Both methods are designed to ensure that adding new, valid blocks is beneficial and adding invalid ones is costly or impossible. So, to recap, data is bundled into blocks. Blocks are cryptographically chained together using unique identifiers. The entire chain is replicated across a distributed network of computers. New blocks are added only after consensus from the network. Why does all this matter? Trust without intermediaries. You don't need a bank, government, or company to verify transactions. The network does it. Enhanced security. The distributed, immutable nature makes it extremely resistant to fraud and hacking. Transparency. All valid transactions are visible to everyone on the network, though identities can be pseudonymous. Efficiency. Can speed up processes by cutting out middlemen. Beyond cryptocurrencies, blockchain has the potential to revolutionize industries from supply chain management to healthcare, voting systems, and digital identity. And that, my friends, is the magic behind blockchain. It's a game changer because it allows us to build trust and security into digital systems in a way we never could before. If you found this helpful, hit that like button, subscribe for more tech deep dives, and let me know in the comments. What other crypto topics would you like me to explain? Thanks for watching, and I'll see you in the next video.